testers, and welcome to another SCP community webinar. My name is James and I'm filling in for your host, Smita. Today we are joined by Andrew Knight from Precision Lender, and he will be talking about how to start testing with Python. A few things to cover before we get started today. SCPCon Virtual 2020 is just around the corner and will be taking place on Tuesday and Wednesday, September 29th and 30th. The two-day online conference will include over 30 workshops, sessions, and sponsored demos for you to choose from, all for only $195. Be sure to visit stpcon.com to check out the speakers, review the schedule, and register today. A reminder, we have an upcoming webinar on Wednesday, October 14th from Jason Wick at Make Music. The topic is the F word, giving great feedback. Visit softwaretestpro.com to register for the webinar and view all the remaining webinars for 2020. Looking to practice your speaking or presentation skills or have an idea for a webinar topic? Webinars are great for both new and veteran speakers, and SDP is looking to fill the rest of the 2020 community webinar schedule. So submit your webinar proposal today at softwaretestpro.com. If you're on social media today and talking about this webinar, be sure to tag us at softwaretestpro and use the hashtag STPwebinar. Also give Andrew a follow while you're at it at Automation Panda. Without further ado, let's go ahead and get started today with Andrew. Here's a quick introduction for everyone. Andy Knight is the Automation Panda, an engineer, consultant, and international speaker who loves all things about software. His main passion is software testing and automation. He has designed and built robust test automation solutions for operating systems, service APIs, and web apps with hundreds of tests running continuously. He also coaches others in good development, testing, and BDD practices. And he currently works full-time as the lead software engineer and test at Precision Lender, a Q2 company. Read his tech blog at automationpanda.com and follow him at Twitter at automationpanda. All right, let me go ahead and give you control here, Andrew.
Thank you, man. Appreciate it. So hello, everyone. Sandy Knight here, broadcasting live from Raleigh, North Carolina. I'm hoping everybody can hear me okay and see my screen. It's quite an honor to be here. So thank you for taking time to listen to me talk about something I absolutely love. So today we are going to learn how to start testing with Python. If you know me, you know I love Python. So one thing to ask is, why is Python so hot right now? If we look at any major index of popular programming languages, such as TIOBE, as well as others, you'll see that Python has grown dramatically in popularity over the past several years. So why is that? There could be many reasons. It could be that Python is just hotness. It's a little bit easier to use than Java, C#, whatever. But I think the reason why Python is so popular is, first of all, because as a language it gets out of your way. It makes it much easier to do the things that you intend to do without having to use as much code to do it. The second reason I think Python is so popular is because the community is wonderful. I'm very much involved in the Python community. I go to all sorts of Python conferences and I write about Python frequently. And all the people I've met in the Python community are just wonderful. So for those reasons and probably several others, Python is on the up and up, and I think it will continue to be popular for quite some time. So then what makes Python specifically good for test automation? Python is a general purpose language. It can be used for multiple things, from scripting to DevOps to data science. But I think Python is particularly useful for test automation. Some of the reasons why it's popular. It has a low learning curve relative to other programming languages. It also has really good tools and frameworks, things like pytest and Selenium WebDriver and requests for making REST API calls. All these reasons make Python really, really good for test automation. And also the fact that it's very heavily focused on the command line. You can easily, type in commands, script things, and go. So I advocate for Python as a great language for test automation. And specifically, I advocate for the pytest framework. Python has a number of test automation frameworks, such as Unitest, Nose, pytest. There's a couple others, but right now pytest is the most popular, and I think that's for very good reason. And that's the pytest is very Pythonic. As we will see in the code that we'll write together here today, pytest lets you write tests very, very simply. Here's the documentation page. You can see just right here, this 2-line function is a full and complete unit test, right? We're going to write tests as functions, not as classes. We're going to use all the goodness of the Python language, and it will come together seamlessly, as we'll see. So with all that under our belt, with knowing Python, how do we get started with Python test automation? First thing to do is that if you're new to Python, you'll need to install Python on your machine. You can go to python.org, go to downloads. The latest download right now is Python 3.8. You definitely want to be using Python 3 and not Python 2. Python 2 has hit end of life. There are subtle differences between the two versions in terms of the language, but the world is now using Python 3, so roll with it. Once you install Python on your machine, what you'll then want to do is install the pytest package. To do that is fairly simple. We're going to use a tool called pip. Pip is the Python package installer. It goes out to the public package index and downloads all the wonderful, lovely Python packages out there. So just to verify, I have Python on my machine. Sometimes you may need to use the Python 3 command. Oops. If the regular Python command doesn't work. And so to install pytest, we'll say pip install pytest. And like I said, if you have to use Python 3, you might have to say pip 3. Now for me, I already have it installed, so it should just say everything's satisfied. But if you are installing it for the first time, it'll take about a minute, no big deal. If you're already familiar with Python programming, you may want to set up something called a virtual environment. Right now, when I did pip install pytest, that would install pytest in the global package space, but you may want to have a local package space on a per project basis. Up to you. I'm not going to go talk about that too much. If you're new to Python, global space is fine. If you want to learn more, look into virtual environments. And other than that, the only other thing you'll need to get started would be a good editor or IDE. There's plenty of good choices out there. Today, I'll be using Visual Studio Code. Visual Studio Code has a great Python extension from Microsoft itself, and they've poured a lot of good development and features into it over the past couple of years. I like Visual Studio Code because it's a nice trade-off between a lightweight editor as well as one with a bit of power behind it. Another good choice would be PyCharm. I use PyCharm as well sometimes. PyCharm comes from JetBrains. PyCharm is more of your traditional IDE. It's kind of big, bulky, but it's got a lot of stuff in there that's really good. If you want to go ultra light, you could use something like Atom or Notepad++ or Sublime. All good choices there. So for today's webinar, I'm not going to be going through slides. I will be doing everything live coding. We will be building a Python test project from scratch using pytest, and I'll be showing code in Visual Studio Code as well as running things from the command line. You'll be able to find all of the code I'm sharing at this GitHub repository. My username, AndyLPK247, and then TAU Intro to PyTest. This is actually the repository that will be used for an upcoming Test Automation University course on PyTest. Make sure you're in the example develop branch, and you'll find everything in the tests directory. So use that as a reference if you want to refer back after this webinar. Oops. So without further ado, let's do some code here. When you're starting with Python, or when you're starting to create Python test automation, the first question you're going to hit is, should I create a new project for my test automation, or should I put my test automation into an existing project? And the answer to that question really is going to depend upon your needs. For example, if you already have a Python project and you want to write unit tests, then certainly you'll want to put your unit tests in the existing project. However, if you're writing, let's say, Web UI or REST API tests or some other sort of feature level test, something that tests the thing black box style, you might want to put them in the same repository. You might want to put them in a separate repository. Typically, what I would say is if your project is a mono repo, meaning everything is in one, then you might want to just put it in the existing repository so that everything can be version controlled together. But if your thing under test is already broken out into multiple different repositories, then making a new repository or project for your test code is probably the better path. Again, it all depends on your situation. There's pros and cons to each approach. For our webinar today, I'm going to create a new project. So all we got to do is make a new directory. By the way, I'm on a Mac, so this is a Unix command line here. And we'll call our project stp pytest example. Oh, wow, I can't even type. stp. This is what happens when we work from home for too long. Oh my goodness. Okay. So we've created our folder for our project. And in Python, it is conventional that we put all of our test cases into a subdirectory named tests. So I'm going to change directory into my new project, and I'm going to make another directory called tests. So from here, I'll switch over to Visual Studio Code. I'll open up our new project folder. Oops, don't want to open space. Oh, beach ball of death. Sorry if my computer's a little slow here. STP pytest example. Okay. So here we have our empty project with our tests directory. In here, we're going to create a new Python module. Python module is just another name for a Python file. Extension is py. I'm going to call this test_math.py. Cool. And just like that, we have our Python file. What we'll do for examples, we will write a couple unit tests showing how to use the pytest framework by the mechanism of just some basic arithmetic. Typically, you wouldn't write unit tests for basic math operations in the native language, but we're going to do that, like I said, just to illustrate how pytest works as a framework. So in here, let's write a basic test. Def test 1 + 1. This is a basic Python function. Def is the keyword that denotes a Python function to be created. Remember, in Python, it's white space friendly, so we don't have squiggly brackets, we have colons and indentation. There's some key things to note here, just starting off. First of all, this is a pytest test. Pytest uses functions instead of classes for test cases. And the way pytest identifies that a function is a test case is that you put it in a module that is prefixed with test_. And inside that module, you put your test functions prefixed with test_. There's a few other variations. I think you could say like math_test or maybe 1 + 1 _test. But conventionally, you'll see prefixes of test_ coming on the front of names. When we run pytest, it will go through all the directories in the project and look for any modules that contain this prefix test. And then inside, look for any functions that contain this prefix test. And it will treat them as test functions. Furthermore, I also like to give helpful names that are somewhat descriptive to our test cases, because when we see test failures, we want to know exactly what the behavior was that failed. So if we implement this function, assert 1 + 1 = 2, we'll make sure that 1 + 1 = 2. Again, basic math operation. This is an assertion, and we're familiar with assertions from other languages. But what makes pytest interesting in how it uses assertions is that it uses Python's basic assert command. Assert is a statement within the Python language. Pytest doesn't rely upon fancy assertion libraries, like, for example, in the unit test library in Python, there's an assert set of methods there, or in, let's say, C# land, you have fluent assertions, right? Many languages have entire packages and libraries dedicated to assertions. In Python, we have a mantra that goes simple is better than complex. And so simply using the assert command is already in the language, it's set up, ready to go. And we'll see in a few moments how pytest actually does some very, very interesting introspection with these basic assert commands. So we'll put the assert command, we'll put a Boolean condition here, and in 2 lines, we have a fully functional test case. So if I flip over to the command line, see we have our test module there. Let's run this new test. Anytime we want to run tests using pytest, we invoke the pytest module. Python is the command, -m for module, pytest. You may see some documents saying just run the pytest command directly. However, I do not advise that. And the reason why is because if you run the pytest script directly, it won't add the current directory to your Python library search path. So that means any of the modules in your current project won't get picked up for import statements. It can be rather confusing. However, if you use python-m pytest, all your local libraries will be picked up, whatever's on this current directory path. So python-m pytest is how we invoke. We don't need to add anything else. From this directory, it will do that discovery for all of our tests. So let's see what happens. Boom. We have goodness here. Let's dissect this. First, we have the banner saying test session starts. PyTest will print some stuff about the platform, the version, all the different packages being used. So we can see we're using Python 3.8.4, PyTest 5.4.3. It'll show the root directory from which we're running. It's pretty helpful. Any plugins that PyTest might be using, how many tests it found, and then it will print a list of all the modules, all the test modules that were discovered. So we have test/testmath.py or test/testmath.py. And then for every passing test, it'll print a green dot. So 100% pass rate, 1 test pass in 0.05 seconds. Success! We have our first passing Python unit test using pytest. Great, that's awesome. So let's go back to our code. Let's ask ourselves a question. What happens when a test case fails? Let's write another test to find out. Test 1 + 2. Bum-bum. So this time I'm going to be a little bit more verbose in how I print this out. I'm actually going to use some variables. A = 1, B = 2, C = 3, assert A + B = C. All right. So we know if we do 1 + 2, it should equal 3. But let's say we deliberately inject a failure. 1 + 2 should not equal 0, so we know this statement should fail. Let's rerun and see what happens. Again, python-m pytest. And boom, same banner, new test, new failure. So again, testmath.py ran 2 tests. one of which is passing, which is the green dot, one of which is failing, which is that big red F. What's really nice about pytest is that it will print all of the failures. So here we have failures. It'll name the test, test 1 plus 2. And then it will perform something known as introspection. For every failed test, it will paste the lines of that code here. So we see the test case, we see our setup. It will mark with this little arrow the line that failed, which was our assertion line. And then with the introspection, you'll see it will substitute the value of any variables. So on one hand, you could see assert A plus B equals C as failing and say, well, that doesn't really help me. I don't know what A, B, and C are. Do I have to go back and debug to find that out? pytest prints it right here. A was 1, B was 2, C was 0. And so this introspective failure message makes it very clear. Oh, duh, I'm an idiot. 1 plus 2 isn't 0. That's why this thing failed. Furthermore, you'll also see the type of failure. So here in test math py at line 10, there was an assertion error that was raised. Anytime there is an assertion that has a false condition, Python will raise this assertion error. And so that should go further to say any unhandled exception within a test case will be marked as a failure. In fact, it's almost more correct to say that exceptions are failures in pytest because assertion error is an exception. So it could be, index out of bounds, it could be a value error, it could be an assertion error, it could be a custom exception that you make yourself. If there is an exception raised that is not handled within the test, but rather bubbles up to the level of the pytest framework, pytest will capture that exception, log it as a failure, perform cleanup, and move on to the next test case. So finally, at the bottom, short test summary info. You'll see failed with the test name or the test module, the test name, and that introspective line. And then finally, a full summary report of 1 failed, 1 passed. So that's really, really nice of pytest to do that for us. Let's go back and fix it for posterity, just to make sure that things will come back to normal. So now I've put in 3 instead of 0. And if I run the test again, boom, everything is passing again. And we're happy. Yay. So that's well and good. From that, we learned that test failures print out extra info, that these assertion statements, even though they are the raw assert statement from Python, that pytest adds that additional introspection to make it very feature rich. And we also know that unhandled exceptions are treated as failures. So that last bit of information raises an interesting question. How do we handle expected exceptions? What if I write a function or method that is supposed to throw an exception? How can I verify that with a test in pytest? Not too difficult. Let's give it a try. Test divide by 0. Bum, bum, bum. We know this should generate an exception of some sort. So let's try this. What actually does happen in Python if we try to divide by 0? If I run this test, we'll see that num1/0 raises a 0 division error. And that's what causes this test to fail. So now we have to add some handling to make sure that 0 division error, when raised, is treated as a success. And to do that, we use something from the pytest module called pytest.raises. So I'm going to say import pytest. Pytest is not just a runner, it's also a library of Python code that we can use from our tests. And in here, I'm going to say with pytest raises zero division error. Now try to do this. So the with statement in Python allows special entry and exit logic. It's kind of like if you were to automatically open and close a file stream after reading and writing. What this with statement does with pytest raises is it says, okay, the next block of code, whatever happens, if it raises the target exception, we're going to move forward and everything's going to be okay. However, if it doesn't raise this exception, then and only then will this raise an assertion error. We're expecting this code block to raise this error. Let's watch it in action. Boom, 3 passing tests. It worked. So we can take this a step further. What if we want to verify things on the exception? I can store the exception object that was raised by saying as some variable name. Then down here, I can make assertions on that exception. I can say assert division by 0 in the string of the exception's value. So here we're actually technically performing 2 assertions. We're making sure that this statement raises an exception. And secondly, we're making sure that exception has a particular phrase in its message. So we give this another try. Boom, we're still passing. That's really sweet. Okay, cool. So let's up the ante a little bit more. With math tests, we typically have multiple combinations of inputs that we need to test, right? Testing 1 plus 1 is great, or testing 1 minus 1, sure, okay. But typically our test cases have multiple equivalence classes of inputs, right? What happens if we try a negative number? What happens if we don't try a number at all and we put in letters, right? All these kinds of things typically use the same test case logic, just with different inputs. So pytest lets us write these so-called data-driven tests with something called pytest mark parameterized. Let's see how we can do this. Let's try testing multiplication. So if we were doing it our old way, we'd say something like assert 1 times 2 equals 2. But what if we could parameterize this? Instead of having hard-coded numbers here, pushing through several different input and output combinations. First step would be to parameterize the test function. So instead of saying hard numbers, we could say assert A times B equals some given product. That's cool. I suppose we could do that. So then the question is, how do we provide these, or how do we provide data for these test inputs? Well, let's make those test inputs as a list. I'm going to call the list products, and it's going to be a list of tuples. In Python, a list is denoted by these square brackets, and tuples are denoted by parentheses. There's a little bit of a difference between how lists and tuples operate under the hood. Things like lists are mutable, tuples are immutable, meaning you can't change them. But essentially, they're all index kind of things. So let's make some tuples that represent different input combinations. Right. Let's say I want 2 times 3 equals 6, because that's going to be the equivalence class for positive integers. I could also do something like 1 times 99 equals 99, because that's the identity property, anything times 1. What about 0 times 99? Well, that's going to be the 0 property, multiplication. I could do something like 3 times, -4 equals -12, because that's a positive by a negative. I could even do -5 times -5, and that should be a positive 25, because that's negative by negative. And finally, to round this off, let's say decimal numbers. 2.5 times 6.7, that's going to give us 16.75. Floating point. So here, the same multiplication function can be applied to multiple equivalence classes of inputs. To get pytest to munch through that table there, I'm going to use a decorator. Decorators go on top of Python functions with this @ sign. So we're going to say pytest mark parameterize. We're going to specify the string tokens of the inputs. We pass that in as a string so that this decorator can split the string by commas and then do the appropriate injections positionally. And finally, we'll pass in that list of products. Remember as well that you'll need to have the pytest module imported, just like we did for pytest raises. That's where it comes from. Don't worry if you're not familiar with Python decorators. In short, think about them as wrappers. Anytime you see a decorator on top of a Python function, whether it's a pytest test function or just a regular function or even a Python method or class, decorators are just wrappers. They provide an outer function that will internally call this inner function so that it can wrap extra logic around it. In our case, for pytest mark parameterize, the extra logic that's being wrapped around is to say, take this table of inputs and call this test function multiple times, once for each tuple in that input list, and inject them into the test function as the arguments. That's what the magic is here. So with this, we can have a data-driven test in pytest. So let's see what happens when we run this bad boy. Boom. So everything's passing again. Great. What's interesting here is we now have 9 tests, right? Even though we have 4 test functions, ultimately there were 9 tests because we added 6 tests to that one parameterized test, if you recall. So that's where that expansion of numbers comes from. Pretty sweet, pretty awesome. So this showcases the basic mechanics of the pytest framework. Let's now move on to test something a little bit more interesting, right? You know, in the real world, you're not going to be testing, basic native math operations. More than likely, you're going to be testing your own functions and methods in terms of like unit tests, or even functional or feature level tests. So let's create a class in Python, and let's write some unit tests for that. What I'm going to do is I'm going to come to the top level of my project and create a new folder. I'm going to call it stuff. And inside my stuff folder, I'm going to create a new Python module called accum.py. And in this accum.py module, I'm going to add a simple class. Class accumulator. What this accumulator class will do is simply keep counts of things. So I'll add an init method. An init method in Python is kind of like a constructor. And I'm going to create a private instance variable named count and initialize it to 0. In Python, the self is the reference to oneself. It's similar to the this keyword in Java, C++, C#. Underscores in Python mean to treat something as a private variable or method, though it's purely conventional. You could access it. There's truly nothing private in Python. But we add instance variables just by attaching an attribute onto the self reference. We don't create variables up at the top or anything. Remember, Python is dynamically typed and you can add attributes onto any object. So that's what we're doing here. We will create a property named count. And this will simply return the private value. This way we can get this count attribute, but we cannot set the count attribute. To change the count, we'd have to call the add function. And we'll say self.count plus equals the additional amount that we want to add. The default for that amount will be 1, but the caller could override that to add even more at a time. So a very, very simple class. The count should only ever go one way, presuming this is positive. And so it's just a little counter, a little accumulator, like a tally. To be able to use this accumulator module inside the stuff folder, we need to turn stuff into a package in Python. To turn a folder into a package, which means we can import it, all you got to do is add this dunder init.py module. When I say dunder, I mean double underscore on both sides. It's a fun little thing in the Python community. We say dunder something, but dunder init.py, we can leave this file blank. But now the stuff package or the stuff folder and all of its modules will be treated as a package, so we can import it off of the Python path that we're currently on. I should also take this time to note that this stuff package is a Python package, whereas the tests folder is not a package. Tests does not have an init.py module, and that is by design. Unless you're doing something very trippy, it is recommended for pytest that you do not make your tests folder a package. Pytest will be able to discover even without being a package. So now that we have our accumulator class, let's write some unit tests for it. I'm going to create a new module under test called test_accum.py, just to keep that parallel naming structure for simplicity. And one moment. Okie dokie. So let's do some testing for it. So I'm going to import it from stuff.accum import accumulator. And see, with Visual Studio Code, I'll just comment here. The fact that it's auto-completing these things means that the imports are going to be successful. So that I've set up my packages right. That's helpful. And also, for the heck of it, I'll import pytest because we'll need that in a little bit. So to write some tests for the accumulator, I can test the accumulator, the init value, and I can do something like this. Accum equals accumulator. I can construct that object. And then what do I want to assert? Assert accum.count is 0 upon initialization. Some other tests I could do, I could say test accumulator add 1. And again, accum equals accumulator. And I'll say accum.add, and that will use the default value. And now if I assert my count should be equal to 1. Can copy and paste this. Whoops. Let's add multiple. Instead of adding 1, we can add 3. Or maybe I want to call the add method twice. So add and then add. A little bit different than passing in a number. Here I'd expect this to be 2. And then because I was using a property, I could say something like test accumulator cannot set count directly. Oops. Make my class or make my object again. And here I'll say with pytest raises, and it should raise an attribute error. I'm also going to do a little nifty thing here. I'm going to say match because I want it to match the proper expression. Can't set, oops, double quotes here. Can't set attribute. That'll make sure not only does it match an attribute error, but it matches an attribute error with this particular message string. That's E. So if I try to directly set the count to something like this, it should throw this attribute error. Okay, so just like that, we've created a very basic class and we've written a bunch of unit tests for it. All of them, again, these are functions as tests. They all arrange, act, assert, set something up, make a call, try to do something. Set something up, make a call, try to assert something. There's nothing terribly fancy about these unit tests yet. So let's make sure that they actually work now that we have 2 test modules. Oops. Well, that was unexpected. That one was successful, but hold on 1 second. I think we screwed up the code. Oh boy, the joys of live coding. All right, let's see. Well, we can use our test to kind of figure out where we went wrong here. So it doesn't like accum.add. I wonder, did I give it a bad name? That should be right. Well, when this happens, we can kind of drill down into it. We can say, okay, I know that the math tests are all passing. So let me just run the accum tests. To do that with pytest, we can actually provide a path. If I say test underscore accum, oh, come on. Tests underscore slash test underscore. There we go. With pytest, you can filter the tests that you want to run. So here I've said test underscore, or I've given the path to the module, and you can see now only the accumulator tests will run. So I'm exhibiting 4 failures here, and they're all in the add method. So something is wrong with this add method here. It doesn't like that for some reason. If this is still too much noise, what I can do, not only can I filter down to the test module, but I can filter down to the individual test case. So we know test accumulator add 1 was having a problem. So let's, if I put the path to the module, put double colons, and then put the exact test case name, it'll run exactly that test. So here we have one failure. It doesn't like this add method for some reason. Why doesn't it like that? Attribute error, can't set attribute. Oh, I know why. It's because I set self count and not self underscore counts. The property prevents me from setting count directly. Inside the class, I have to use underscore count. Wow. Ladies, gentlemen, and everybody else, this is exactly why we do unit testing. Because even with the script off screen on the side, I still screwed up the code. Unit tests help check ourselves before we wreck ourselves. Oh my goodness. So now that we fixed it, let's try this again. Wow. Wow, I can't believe I messed up live in a webinar. That's okay. It was a learning experience for everybody, and it demonstrated a wonderful point. Okay, so let's run them all again. There we go. So here we can see with our test accumulator, all of our unit tests for that class are now passing. We found a bug, we fixed the bug, tested passing again. Test-driven development is awesome. Okie dokie. So one more thing before we open up to questions. If you take a look at these tests, you'll notice something that's a little bit perturbing. And that is that there's a little bit of code duplication here. Every single one of these test cases uses this line to initialize an object. Accum equals accumulator. And here in Visual Studio with it highlighted, you'll see boom, boom, boom. It's constantly repeating. So pytest has a way to eliminate that duplication. Unlike most XUnit style test frameworks like unit test or JUnit or NUnit, pytest doesn't have your traditional setup and cleanup methods, right? In an XUnit style framework, you would have a test class with a setup method and a teardown method, and those methods would be called before and after every single test method inside that class. But because we're doing functions here, we need a different way of handling that. And with pytest, we use something called fixtures. pytest fixtures are basically functions that handle setup and cleanup logic. And fixtures are really nice because they rely on dependency injection, and they are completely reusable and shareable across the project instead of being locked into just one test class. So to write a fixture, all we have to do is make a function. I'm going to make a function named accum, and it's going to create an accumulator object and return it. Kabam! To make it known that this is a fixture, we're going to attach a pytest decorator, pytest.fixture. Fixtures are just functions that return objects for setup. So now that I have my fixture here to create my accumulator object, I need to have it called by the tests that need this fixture. So if I look here at this one, I can get rid of this duplicate line, and as a function parameter, I put the name of the fixture. When pytest runs this function, or I should say when pytest discovers this function, it finds, okay, this is a test function because of the prefix. pytest will introspect the parameter list. Just like it did with the pytest mark parameterize, it looks at the parameter list. Here, it will check all of the parameter names to see if it has any matching fixtures for that parameter name. So here, since accum is the name of a fixture that's available, pytest will automatically call this fixture and inject the return value as this value as an argument. So now this test function can just use this accum object that was injected by this fixture that was automatically called as part of setup. And with that in mind, we can hack and slash this, y'all. Check it out. Boom, boom, boom. So much code gone. So nice. Oops. There are many things you can do with fixtures. You can have a function with multiple fixtures. You can have a function with no fixtures, as we had before. Fixtures can declare different scope, meaning they can run once per test case, once per module, once for the entire test run, so you can control that. Fixtures can also do cleanup. If you wanted to clean up, you could say yield instead of return to make this a generator, and then do something like this. Anything after the yield statements will be run after the test is complete, regardless of the exceptions raised. But we don't need that for R, so we can keep it simple. So now that we've used this fixture and really revamped our test case here, let's rerun, and everything should be handy dandy. Boom, sweet, awesome. So y'all, in a nutshell, that is how we use pytest as a functional test framework. What I've shown here today are the mechanics of the framework itself, as well as how to write effective unit tests for a class. PyTest is more than just a unit test framework. It is also a feature test framework. So you can use it to test things like REST APIs and web UIs. You can import any modules you want into PyTest for any kind of testing that you need. If you want to learn more about higher level testing, in the example project I shared, oops, I do have an example of a REST API test using the requests module, which is one of the most popular packages in Python ever. And it's very simple. You can see here, you have a URL, you say get for your URL to get a response, you parse that body as JSON, and then you make assertions on it. All PyTest. I have another example on Test Automation University. If you want to learn how to do web UI testing with Selenium WebDriver in Python, you can take the course. It is called, oh boy, taking a minute to load here. Here we go, Selenium WebDriver with Python. So that is a multi-part course, goes through all the things of how you would set that up. It uses PyTest as well as Selenium WebDriver in Python. So feel free to check that out, y'all. So yes. With that, I guess it's time to open up to question and answer.
Awesome. Thank you, Andrew. That was great.
Oh, thank you.
We have quite a few questions, so we're going to try to get through as many as we can right now. Not the ones that we don't get to, I'll go ahead and send to you in an email, and we can reach out to those people, or you can send us answers and we can post that with your recording.
Sounds good.
All right, so first question. Can PyTest be run on top of Anaconda, assuming it was added to it?
I don't see any reason why not. Okay. I know Anaconda has some peculiarities with how it handles certain packages, but Python is Python, so I would presume it would just run just like any other module.
Okay. Can you pass any flat file, like a CSV file of data here, for example, if data was in a file?
Absolutely, yeah. The best way to do that would be through a fixture, as I showed. Typically for test automation, you want to read in files one time for the entire test suite rather than on a per test basis, assuming that the data is shared by multiple tests. So I would say write a fixture function, set the scope appropriately for your needs, and then in that fixture function, use a CSV reading library to read in the file, parse it, and pass it along either as like a list or a dictionary, whatever Python data structure makes most sense.
Okay, perfect. Looks like 2 questions, pretty similar, so I'll ask both of them. Are you assuming that the count gets incremented sequentially? And is there a possibility that the count value will be different under any circumstance?
Oh, in my little example,
Right.
I mean, I suppose. I mean, that was just meant to be a trivial little example to show how you would unit test a class. So, I mean, yeah, you could. I mean, you would call that little incrementer add method whenever you would want, I guess. Yeah, I guess you could end up in weird things if you try to do parallel stuff and you don't have the right controls. But again, keep in mind it was just a basic, simple code example to illustrate how to use unit tests for a class.
Got it. Perfect. Let's see. Next one. Please explain why adding 10 raises an error.
Great question. So this is more of a Python language thing. Let me share my screen again. Okay, so oops. So in Python, if you make a class and you set something to be a property means that you can get the value, but you cannot set the value. So because I've made count without an underscore to be a property, I can do things like I can refer to count in my tests. Like here, we're getting count as an attribute, no problem. But if I were trying to directly set the count, it raises this attribute error because the property as wrapping this method here for count says, no, I'm not letting you set the count value. That is not allowed. We're going to raise an error. It's like in Java, if you were to create a private instance variable with a getter method, but no setter method. So this is blocking the setter. That's why this raises an error.
Perfect. All right. Next question. Can it link to WebDriver / Selenium?
Absolutely. Absolutely. The best way to handle that, you'll see this in the Test Automation University course I created. The best way to handle Selenium WebDriver would be create a fixture to initialize your WebDriver with whatever options you want, and then inject that driver object into the individual test cases. And then once that driver object is in the individual pytest functions, then you can just call it like you would. You can pass it further into page objects. You can call, navigate to your page and click and get the text of elements and stuff. If you are using page object pattern, I would actually recommend 2 layers of fixtures. Your first fixture would be creating the WebDriver instance, and then you would have another fixture that would receive that driver object from the first fixture and construct the desired page objects. So that way you could directly declare in your pytest functions what the page objects are as parameters and just have them injected to you. So like if you're doing a Google search, you can just straight up start from the Google search page.
Got it. Perfect. A couple more here. Can pytest generate test reports?
Yes, yes. So what you saw today was just what it pukes out on the command line. That's really nice for like manual debugging and stuff. It's not so great for trying to report to a team. There are a couple ways you can get reports out of pytest. If you're doing something in a continuous integration environment, say with Jenkins or with TeamCity or any of the Travis CI, right? You can have pytest generate a JUnit XML file, which is nothing more than just a report that reports the test passes and failures in the same way that JUnit does. And JUnit is kind of like the de facto standard of what all these CI servers use. So if you give that job, that particular file, it'll just kind of eat it up and boom, and then put out whatever charts and stuff. And so that's one way you can get reports out of it if you're using CI system. Another way to get reports out of pytest would be there's a simple plugin for pytest called pytest-html. And if you install that, pip install pytest-html, and then I think there's a few command line arguments it might add for the pytest command, you can generate HTML reports for your results. I will warn you that report is very, very basic and not very customizable. So then the third alternative would be you make your own pytest plugin to generate your own reports in the fancy ways that you want to see fit. I didn't talk at all about pytest plugins in this, but just note one of the advantages of pytest is it can have plugins. You can insert extra hooks, and you can either pull down plugins from pip, or you can make your own and release them out there. So it's a very extendable framework.
Awesome. Perfect. We got one more. Let's squeeze this in. Can you suggest a module for desktop automation?
Oh boy, desktop automation is difficult. So I know in Windows 10, I believe, they have a WinApp driver, which you can automate certain Windows applications like they were web UI applications. Other than that, most likely you're going to have to rely on some sort of like image capture, picture matching kind of stuff for desktop. That one historically has been rather tricky. Another path you could take is, I know that some operating systems like Windows, through their accessibility interface, allow for automation. So like for screen readers and stuff, it's not the primary use of that technology, but it is a secondary way that you could kind of get in under the hood and do your automation interactions.
Perfect. That was great. That was an awesome Q&A. So with that, thank you so much, Andrew. We enjoyed your presentation and your demos today. Thank you for doing this for us. That was great.
Oh, it's my pleasure. Thank you for inviting me and hosting me. It's my pleasure.
Awesome. All right. So just a quick reminder before we get out of here. Register for SPCon Virtual 2020, where you can sharpen your testing skills and learn new skills from the comfort of your own home or office. Visit spcon.com to check out the 2-day schedule and see who will be speaking September 29th and 30th. Our next webinar will take place on October 14th with Jason Wick. He'll be doing a presentation on giving great feedback. Visit softwaretestpro.com to sign up for this webinar and view what we have left for SCP in 2020. If you'd like to be considered for a webinar presentation or have a great idea for a testing topic, visit softwaretestpro.com today and submit your webinar proposal. And with that, thank you again today, Andrew. That was awesome. Thank you again for everyone who joined us today. Have a great day, and we hope to see everyone online at SCPCon Virtual 2020.